People always think we're attacking NASA, and we're actually NASA enthusiasts when it comes right down to it, right? We're space enthusiasts. We want accountability. We want disclosure. We want to see what's actually there, and we will accept the limitations. We'll support the limitations on what's capable of doing. We don't need to keep researching in and find out, oh, all we're looking at is CGI. If you can't do it, say so. Well, the Russians paraded their military stuff down the street, and America didn't do that, so they had to launch a few.
It was a race. It was a race of them too. I do understand where they came from. Everyone understands. But I think the time has passed to not be carrying the same sins anymore. I mean, okay, it was a white lie. It ended up not having a bloody war, not spilling up blood of humans around. Okay, they did what they wanted to do. It worked. But now I think this is holding back people from actually achieving a few nice goals.
That's exactly the way I think a lot of people now view it. That was all in the past. We understand why it happened. We didn't like why it happened, but we understand it. It was geopolitics at its worst. But now we're into a completely different environment where we want to be able to travel in space. NASA are there trying to do it. Now, they're losing out because the Chinese Space Agency understand much more about what is going on and how to get into space and what to do when you get there and how to protect humans. The Chinese haven't tried to send humans to the moon yet. They probably will once they can do it, because remember that famous phrase that the Russians were used when they were asked in the 60s, when are you going to send men to the moon? And their answer was, when we can ensure their safe return due to the dangers of radiation. They understood the problem. The only people who didn't understand the problem were America.
They did understand. It was a fantasy. It was a show. That's why they had the show going on. Can you imagine? It's like the scientists going in the room, having time being your worst enemy, and having nothing sorted. It's like, we haven't sorted the batteries, we haven't sorted any automation on how everything is going to be automated in the landing. We don't have any kind of equipment that can do this kind of automation. We haven't tested anything. In order to put anything to work, you have to test it. The only testing that they did were a few failures that you were showing on the channel. The LM that Armstrong by chance escaped it the last minute. How many sloppy things have they done? It's like, how many?
They're still doing it now. Just hearing that Artemis 2, we just had Artemis 1 that was supposed to work. Artemis 2, which is going to be astronauts orbiting the moon, is not going to be flying for 27 months. That's over 2 years. Why is it taking so long? Oh, probably because they've got to rebuild the launch tower, which got badly damaged in the first launch.
I don't think they will. I think they're going to modify a launch for Musk.
Musk is the one who's going to be providing the lander, but that hasn't been tested yet. They haven't even launched Starship. They haven't gone into orbit yet. I mean, it looks very pretty. It's got its stainless steel heat shield, we're told, but it hasn't been launched yet, let alone land on the moon and be prepared for humans to be on board as well. I mean, that's a major advance. I mean, even Apollo went from Apollo 8 to Apollo 11 before they could go from orbiting the moon to landing on the moon, we're told. I mean, that really wasn't a real story. It was just a fantasy. But if Musk is going to do it, he's got to launch his rocket and get it off the ground into orbit, hasn't been into orbit yet, and then get to the moon, and then get down onto the lunar surface, and then get off the lunar surface and back to Earth. That's a major undertaking. And he's got Twitter to sort out in the meantime, so he's got his work cut out. Whether he'll do it or not, I don't know, but it's nice watching it.
I still think it's all fantasy when you come down to it, because how are they going to step out of a craft into that torr value with those suits? You take a basketball, it's got 8 psi in it. If you can take your hand and squeeze it flat, that's not even close to what those gloves are going to be involved in, right? And low Earth orbit, they're not going to do that. Even if they drop the suit down to 5 psi, it's not going to happen.
Yeah, the proper suits would have a lot of structural elements in parts so that it doesn't get bloated.
And the gloves that have to be completely robotic.
Okay, you may be doing some hypotheses. They may be correct, but physics has a habit of giving you surprises all the time. So it has a character. As deeper as you go, more character appears. You may be having small, rules like electrode deposition. If you put something positive and negative under a liquid, then the ions start moving towards the negative, and you get electrode deposition. You take the material out. It's not deposited, of course, throughout the surface of your material. It's rough. It starts making trees. And why is it making trees? Because the electricity has a more affinity on the new molecule, has a bigger affinity to stick on the edge of a rod. So you get a lot of things you think are going to be different, they end up being different. So the best thing that we do here is the equipment. And I'm very happy we can be following through this, because I was always thinking, when Marcus was talking about the vacuums, I was always thinking to myself, I hope I could help them. So yes, we do have the professional equipment. It costs like thousands. Even the turbo pump that we have costs 10,000 euros, 20,000. Even the links to put together cost a lot. So yeah, guys, I don't think NASA was expecting people to be having a proper lab, and neither were they expecting a proper university, a proper institute to be doing these kind of tests, because I guess they were relying on the kind of trust between countries.
The chamber you have for that equipment is what, a half a cubic meter?
Yeah, around there. It's 1 meter tall and around 50 centimeters thick. If you see the walls, you'll be amazed of how big they are.
Tell me, how much time do you have to wait in order to lower the vacuum?
It depends on how many liters you can evacuate. We have a huge pump. It goes down to 20 minutes, around there. It depends how fast your pump is. Generally, if you have left the vacuum chamber a lot of days out in the atmosphere, it will have absorbed some moisture in the crystal lattice. The walls will have absorbed some moisture. You have to wait a bit more because it's spitting out the waters. Still, you see how thick the walls are.
This particular chamber here, he says -6. And then I guess you could see that the turbo pump is right in the pipe itself. This is the same pump I have down here. Then he's got one of these big turbo pumps.
Yes, there are two different types. There are roughing pumps that bring you around to the 10 to the -3. But there are different pumps. There is one called oil diffusion. You spit some oil, like a mist, and all the atoms that happen to pass by get trapped into the oil. The problem with the oil diffusion pumps is that some oil will travel through and reach your semiconductor.
The vacuum is pulling it against the seal at the same time. It's still down like that. Imagine the spacesuits and the gloves and the helmet,
Being in
where
reverse.
the air is inside pushing it away from the seal.
And that's
How much you'd have to torque those down.
And there's your copper seal.
Exactly. That is one use only. Imagine. You can only use that thing once. It gets clamped between the two things you want to put together and becomes a seal. But that are the seals that we use for high vacuum. Those are the seals. Those rubber gaskets that you see are worthless for 10 to the -6. This is a rubber gasket that you're showing now. This is good up to 10 to the -3, 10 to the -4. We cannot use rubber under that vacuum. It doesn't seal, it doesn't allow you to have a vacuum because it's losing the vacuum all the time. You cannot have a vacuum with rubber. And you cannot even use epoxy.
Those are two high voltage rods that he has going up through here too, I guess.
We use high voltage inside the vacuum to make the atoms go in the way we want. If we want to bombard and make an ion implantation on a substrate, then we do energize the atoms. They become positively charged, and then we do put a voltage difference of volts, and so they start moving in extreme speeds, and they impact some substrate, and they become part of your semiconductor. There are a lot of reasons why we do use high voltage. That is a plasma trap. What you do is you ionize the molecules that happen to be around, And once they are ionized, you can direct them, because if you're positive, what attracts you? The negative. So you energize the atoms with the goal being to get rid of them, yeah? You have some atoms flying around in your chamber and you want to get rid of them. So you do your rough pumping first. Those molecules are few and far apart. You need other means, and the means that we use are those kind of things. There is a thing that ionizes the atoms, and then once they're ionized, they can easily be manipulated to go somewhere with electric fields. A plus is attracted to a minus. If something is solid and you give it more energy, it becomes liquid. If you give it more energy, then the atoms inside gain so much kinetic energy that some can jump over into the atmosphere and they can liberate themselves into a gas. Now, if you take a gas and you put some more energy in the form of either thermal energy or electric energy, then you get into a state that's called plasma. In that state, if you have molecules, they will gain so much energy that they will separate. And you get a soup of positive ions and negative electrons whizzing around. So it's a soup of positive atoms, positive ions, and negative electrons, all being whizzing around. So if you are from the plasma now to tell all the atoms to go that way, then you put in that way, you put a minus. You put an electrode with a minus, with some electrical potential, and you put a plus behind. So those atoms in the middle that are positively charged, they have a plus behind them, and a minus in front of them. They will all go that way, yeah? So that's how you gather them. Not a mechanical way, it's an electrostatic kind of trap.
So that actually pulls it out to get it down to that level. You need to have that kind of technology to get down past -6.
Yes, because with the mechanical...
Unbelievable.
To catch every rogue atom whizzing around, because you're lowering your vacuum, and suddenly you don't have like 1 million atoms per centimeter or whatever. You do get 10 atoms in 10 centimeters. So it's quite hard to get rid of them. And so they're utilizing electrostatic traps.
So how is the vacuum being measured when you get down to that level? Are you using a gauge or are you using a mass spectrometer?
You use this kind of traps. We do use that gauge that we use. It traps atoms and it counts how many atoms are...
okay, so you can't physically use a mechanical gauge at that point.
You don't use mechanical gauges, you cannot. Yeah.
Because the force is too great, it'll break the gauge, right?
No, it's too tiny to pick up. We are talking about individual atoms now. We're not having something tangible.
And we think we're going to travel in that environment. I mean, right now what you're telling me is that traveling in space is a true showstopper.
It is a showstopper because we do have to do a lot of engineering in materials. You cannot go with rubber gaskets. You cannot go with 1 millimeter of aluminium. It's all a joke. Yeah, it needs a lot of engineering for that, and that's why we all have seen lower Earth orbit. Because it's quite hard. Vacuums are quite hard. And NASA is still counting on the fact that not many people do know about vacuums. Even guys in physics, the people that we have in the physics in the university. Okay, the students start with classical physics, pendulums, and all the classical physics, and then you go into electricity, electromagnetism, you do get to know your maths, and by the time you graduate, you have no idea, even still, and then you do your masters in the material sciences, and you still have no idea, because all the machines are already made. You made the vacuum machine, it's already made. And even if you become a physics professor, most of those labs are intact. A lot of doctors do copy and paste, because that's the way to be, because it's not the research that you do, it's the amount of research that you do. So, the good research gets shoved underneath a lot of bloated stuff. It's very hard to get into proper physics to see vacuums, and even the professors that are into material sciences, very few of them have built machines by hand, and very few of them do appreciate the problems that you get. Most of them have read the kind of manual that says, look, our vacuum chamber goes down to the -6, -7, it needs this kind of metal gaskets. But tell me, how many people do you know? Even at our university, only, 4 people do vacuum stuff. And the university is huge. It's the biggest university in Greece.
So you actually built that machine?
Yeah.
Yeah, that's the difference.
That was my purpose, because I had reinvented the solar cells. By the time I started my research, what they had already done at the AT&T labs in the 80s, they were playing around with semiconductors and doping to change their optical and electrical characteristics. And there are other ways to do the electrical separation. If you are to build a solar cell, physics starts easily. It tells you that, look, when there is a photon hitting and being absorbed, hitting your hand, for example, hitting something that is not transparent, the photon is an electromagnetic interference. As it passes by the atom, it might, if it has enough energy, it might take an electron and strip it away and pull it away like 100 atoms away in the silicon. If you do the traffic man and you tell it, look, all the electrons go this way, then you do get a solar cell. If you don't do the traffic man and you allow the electrons to go back and travel back to the atom, because the electrons are negatively charged and the atom is missing an electron, so it's positively charged, so they're attracting each other. If you leave it, the electron is gonna climb, it's gonna go back and fall back again into the atom, so you get the energy back as heat. That's why you heat up. So what I did in the solar cells is I reinvented the way they do the charge carrier separation, and that's the biggest problem they actually have now. The recombination that they do have, they're losing on efficiency. So if I were to give the plans to the 2 or 3 foundries we have, TSMC or any foundry that does print out your designs, they would have copied everything before the email arrived to them. So there I was. I had to follow up and see what a physics guy sees in 5 years. So I was a computer scientist. I did electronics. I did hardware design. I can design the chip inside, the actual processor, and then I had to see what the physics guy sees, but not epidermically, not superficially. I had to actually build the machines. It really gives you a lot of insight. It really does. You have to see it first, and that's how you can make your own theories and advanced physics. Because if you are to be another parroting away what everyone else sees, you are never gonna think outside the box. You are never going to advance your science.
We aren't the sort of scientists that you are. We just have an interest in what we see, and we question things. We say, how did that work? And why is that working? And why isn't that working?
Thank you so much, all of you, for the invitation. Thank you so much for all your work. It's been my pleasure, trying to help you. And I will follow up with a better video, seeing the actual stuff happening. I hope I help out with the channel, and I'll be very happy to see you every time I see you. We may be scientists, we may not be scientists. Everything is made by humans. If you have enough analytical skills, you can conquer anything. And one thing that they teach you at the university is that, look, in high school, you were memorizing stuff. In the last days of high school, you were taught to prove things. And in the university, you learn how to search for your own questions and answer them. So they give you the tools. If you do one science, to be able to conquer another science. This is the tool, the analytical thinking. So you've done so nice work on all, your analytical, your thinking, your conciseness, your presentation skills is top notch. Thank you so much. inviting me. Thank you so much.